for attending today's webcast, Energy Efficiency and Net Zero Buildings in New Construction. I am Arliss Reynolds with Opinion Dynamics, and I'll be the moderator for this session. We'll start this webcast with 4 quick housekeeping announcements before moving to our presenters. First, thank you to all of our sponsors and ally members for their support of the Energy Efficiency as a Resource Conference and ACEEE. Second, throughout the presentations, please use the chat box to ask questions of the presenters. We'll address the questions after the presentations are complete, and if we don't get to your questions during the main session, you can join us for the 20-minute Zoom session following the main session. Third, please check out your conference app for some valuable resources. You can find the presenters' PowerPoint slides on their page in the Program Participants section, and we ask that everyone complete the conference evaluation in the Resources section. Finally, all presentations are being recorded and will be available for on-demand viewing within a few days. Now I'd like to introduce our distinguished panel of speakers. They are Forrest Tenier-Gessner, Building Performance Specialist with PAE Consulting Engineers. Forrest is speaking on behalf of Ellen Shepard from the Energy Trust of Oregon, who got caught in a storm today. We have Cheryl Temby from New Home Construction Manager with ICF, and Jillian Winterkorn, Energy Efficiency Consultant with Eversource. We'll start with our first speaker, Forrest Tenier-Gessner, who believes that a successful project requires close collaboration between creative and technical consultants and treating each building as a dynamic ecosystem. He creates energy-efficient, flexible designs, concentrating on passive systems first, with artificial systems in the background. Forrest will describe the Energy Trust of Oregon's program and strategies to advance energy efficiency and net zero in the new construction market for non-residential buildings, and will share a few case studies from the Energy Trust of Oregon program. His presentation is titled, Driving and Sustaining Innovation on the Path to Net Zero.
Thanks, Arliss. So, as Arliss mentioned, I'll be stepping in for Ellen Shepard today, and I am with PAE, where we try and balance people, planet, and profit in all of our designs to help solve the planet's energy and water challenges, and working with our clients and working with our allies, such as the Energy Trust of Oregon, to drive more innovative solutions in the work that we do. Oftentimes in evaluating how we are tracking towards sustainability, we look to different certification programs. And in Oregon, we're very fortunate to have the assistance of Energy Trust of Oregon and their Path to Net Zero program, which we are a design ally within. And they help focus us around energy efficiency and specifically a goal of net zero ready buildings. So Energy Trust of Oregon is an independent nonprofit that works with some of the investor-owned utilities in the state. And their primary goal is providing clean and affordable power to everyone. Some of the key milestones that the Energy Trust has achieved throughout their time in Oregon since 2002 are getting 7 million cars off the road with the equivalent carbon reductions that have been achieved through energy efficiency, and implementing energy efficiency programs across residential, commercial, and industrial projects throughout the state. And within their commercial program, one of the more innovative solutions that they've developed is the Path to Net Zero program. This program has been around since 2009, where it was initially established as a pilot project, where they did an extensive study of what it takes to get projects to align with the Architecture 2030 challenge. At that time, the Architecture 2030 goals were a target reduction of 60% below the existing building stock from the CBEX 2003 baseline data. And currently, they've progressed along the track of Architecture 2030, where the current goal is an 80% reduction from that established baseline. So by establishing targets for projects early and having a kind of focus structure that looks at very, very specific goals and a projection of early design assistance and technical assistance throughout the project life, the Energy Trust program is able to integrate more holistically into the building design and help project owners achieve a greater sustainability in that process. Also aligning with the Architecture 2030 Challenge, the program does specifically use the Zero tool and other resources that the architects and others in the community are familiar with already in tracking their own progress towards that goal. So some of the ways that Energy Trust supports us as design allies is through these technical assistance funding mechanisms, getting project teams together early in design. There's support for having a more comprehensive discussion around energy efficiency and specifically talking about what the target is for the project. As I mentioned, the Path to Net Zero program is focused around Architecture 2030, but the whole buildings offering is open to all projects that are hoping to achieve a minimum of 5% energy reduction beyond code. And so, due to the success that they saw early in the Path to Net Zero projects, they shifted their focus and they opened up the program to be available to all projects that were looking to do energy modeling and once again, a more holistic, comprehensive building design pathway. And so these funds are available to the project owners and to the design teams to help do more comprehensive technical studies to target these more aggressive energy reduction targets. And so, as you can see from the funds here, it's not fully offsetting the cost of the things. There's still some stake for the owner to put into doing these studies and committing to actually achieving the goals that they're trying to achieve, but it is a substantial offset. And so it really helps get some of our clients on board early on. And as a design trade ally, but it's a great partnership in being able to come to them and say, these are the services we can offer, and this is the help that you can get in including those services and making it more accessible to projects of a range of different sizes across the state. So, within the focus target of achieving net zero ready buildings, there's a wide range of different efficiency measures that the program is seeing. And this aligns well with things that we see in the design industry, that when you're looking at a project and targeting these aggressive energy reduction goals, the first thing that we always look to is understanding what are our environmental conditions, what is our climate, and how can we work within those conditions to reduce our overall loads in our buildings through measures like our envelope measures, which you can see in the count of measures that the program is seeing. It's extensive envelope measures that are being implemented. Other passive measures that we would look to and that they see in the program are natural ventilation and passive cooling measures. And then reducing down equipment loads through high efficiency lighting, controlled outlets and plug strips, high efficiency equipment. All of those things are kind of key to reducing down the building loads. And then once that's been addressed as comprehensively as possible, the projects will look towards choosing the most efficient system to implement into the project. So the last piece of that would be looking at renewables to offset the actual building energy consumption. And by having this framework within the utility incentive program, it helps get project teams all aligned, and it creates a more integrated design process. It creates a better framework for that process, and it provides assistance along the path of doing that. So, the program sees projects at a lot of different stages. This is the 2020 incentive projects that have pursued or are interested in Path to Net Zero. There's a lot of interest early on, and then as projects progress, they move into that preliminary stage where they've committed to doing the analysis and actually achieving the target. And then confirmation comes through the energy modeling that our design teams are doing. And then, the post-occupancy stage include verification and commissioning, and then, final certification of the project at the end of construction. Some of the different institutions that you see, the different building types that they've seen across the program, range from, small to very large multifamily projects and all sorts of institutional projects through universities and government. A couple hospital projects, and one of those we'll get to as a case study, which is a great example of how this has helped drive greater equity across the state. And then a lot of school projects, and I'm sure others who work within net zero design and net zero ready design schools are an obvious target just because of the commitment and the investment from the community at large in our schools. So get into a few case studies here that have come through the program, and there's just examples of kind of the range of projects that the Path to Net Zero program has seen. I mentioned, as a medical facility, the Yellow Hawk Tribal Center is a great example of how the program has influenced more remote areas of the state. This was a healthcare facility that served the Umatilla tribe, and what they were able to implement in this project was really outstanding. They did a lot with passive design strategies, really bright opening environment, getting daylight deep into the spaces with skylights and clear stories. The active systems that they were able to implement were a VRF system and a heat exchange with the VRF and the domestic hot water. So they were able to preheat a substantial amount of their domestic hot water with that VRF system. Once again, on the upgraded envelope, just reducing down the loads. And then by having as much daylighting as they had within the space, they were able to, not only reduce down their loads with the active lighting, but really use that lighting as minimally as possible. And so this was a pretty outstanding project for the program. This is a project that PAE actually had the pleasure of working with. And it's actually 3 different school projects for the Reynolds School District, which is an underserved district within our community. And so we were able to really upgrade the facilities for that school district, doing a prototypical design for the 3 schools that was really focused first on maximizing opportunities for the passive systems within the schools. There was an educational aspect to the passive systems as well as energy efficiency, in that we used a green light system that indicates when the conditions are right and gets the children in the classrooms to say, hey, it's time to open up the windows. And so once they go and open up those windows, there's a switch that shuts off the HVAC system serving those spaces. And so it can operate just in a passive cooling mode during those periods. There are other educational aspects as well with dashboard systems in the classroom spaces or in the main school spaces. And then obviously using the other strategies that we've already mentioned, LED lighting, advanced daylighting, and then high efficiency systems with VRF and heat recovery ventilation. These were a really big win for that whole community, and a great example for the path to net zero. This third project was a great example of a smaller project that the program's able to work with. This is a prototype design for a fire station for the Clackamas Fire and Rescue District. Once again, similar strategies. They followed reducing down the building loads, reducing down the loads of the ventilation with the ventilation heat recovery, and then doing LED lighting, and they did a fairly substantial solar array on this project as well. And then the last project here is the Multnomah County Courthouse, which was the largest project to date for the path to net zero at 400,000 square feet. Really outstanding example of what larger projects can do within the program. And they did a lot of passive strategies, utilizing natural ventilation where possible, daylighting, and a very high efficient envelope. And then they implemented chilled and heated beams and heat recovery systems throughout the building, as well as LED lighting controls and efficient domestic hot water systems. So a great example of larger project within the program. And with that, I will leave our contact information and wrap it up and hand it to the next presenter.
Great. Thank you, Forrest. And we really appreciate you stepping in last minute to share some really great stats and case studies about this program. Our next speaker is Cheryl Temby with ICF, where she works with the Michigan utilities on energy efficiency pilot programs and managing the Energy Star rebate program for high performance new homes. Her previous work includes energy and climate master planning and ground source heat pump market transformation for the state of New Jersey. Cheryl will share results of a pilot program aimed to demonstrate and scale the new construction of affordable all-electric and net zero homes serving low and moderate income families. Her presentation is titled, Bringing High-Performance Electric Homes to All Customers.
Great. Good afternoon, and thank you, Arliss, and to the folks joining the session. I'm going to switch it up by talking about the residential segment. As the home building industry evolves and policies around carbon reduction come online, this afternoon I'd like to share learnings from the all-electric new home pilot currently being implemented in Michigan. So this pilot is a collaboration between Consumers Energy and the National Resources Defense Council. Consumers Energy serves 6.7 million customers, providing both gas and electric service in Michigan. It will also be among one of the first utilities to go coal-free by 2024, with no more than 60% of its fuel mix coming from renewable energy by 2040. So combined with the demand side energy waste reduction programs, Consumers Energy will be on that path to achieving net zero carbon emissions by 2040 while meeting Michigan's needs. Our other collaborator, the National Resources Defense Council, is a nonprofit environmental advocacy group with 300 million members and 600 staff. I work for ICF, which is the implementation contractor to Consumers Energy residential waste reduction programs, and I'm also the pilot lead for the first phase of the pilot. So back in 2019, given the shared vision of the collaborators and the way that we use energy is generated, distributed, knowing that is changing, it was determined that we needed a pilot that explored the future state of new homes. And so fundamentally, it would have demand side measures and on-site generation. It would also include cold climate air source heat pumps. And along those lines, the most recent US census shows that Michigan and its neighboring states in the Midwest have some of the lowest rates of installing heat pumps in the country, for reasons that are probably best left to discuss in the Q&A. The third requirement is that we need to keep scalability in mind. We are not just after, getting the higher end custom homes to be net zero, but we want to see traction in our affordable and moderate housing segments as well. And so, because of the complexity of what we are trying to achieve, we took a more agile minded approach to development. So, in phase one, we focused on building 4 all electric homes with on site PV to understand the benefits and cost around the investment to the homeowner and to the ratepayers. In phase two, we focus on scalability and market acceptance of these net zero homes. So let's take a deeper dive into phase one. So this photo was taken by drone by one of the builders in late September last year, and it shows the basement walls being set on the 3 sites. The 4th home is about 2 miles away in a different neighborhood. All 4 of these homes have since sold. These demonstration homes contribute to efforts in the city of Kalamazoo to bring high quality, affordable, sustainable housing with low utility maintenance costs to the underserved core neighborhoods. These homes, as you can see, are actually infill projects within the city's core neighborhoods. But as a market transformation pilot, there is this need to facilitate and educate so that builders and customers alike can be exposed to the technologies that are connected with net zero. And so these technologies, while offering the greatest benefits, also require some of the highest capital investment, and specifically the cold climate heat pumps and rooftop PV systems. So phase one, again, taking this proof of concept approach to program development, has the objective of demonstrating quantitatively and qualitatively the performance of an all-electric home with significant solar PV on site to bring these homes to net zero energy. So as part of that, the technical requirements are that the on-site PV is also fortunately a measure in Michigan, and so savings can be claimed for this. The phase one systems are intelligently designed and they drive the homes as close to net zero as possible. The rooftop PV systems are sized to be about 80 to 85% of the energy consumption on an annual basis. And that's really to avoid overproduction and stay in compliance of the current utility tariffs. So again, just running the small scale pilot with the initial phase of demonstration homes means that we can really understand the equipment investment versus the benefits to the customers and to the utility bills. But at this point, I think it's worth introducing the human element to the discussion. And a key piece has been the collaboration with the Kalamazoo Attainable Homes Partnership. It is a local initiative which comprises the Home Builders Association of Western Michigan, its builders, and nonprofits in the city of Kalamazoo, Michigan. The vision of the Kalamazoo Partners is to produce quality housing with low operations and maintenance costs. And their objective has been to build 100 units over 10 years. These 4 demonstration homes are from the 2nd year of their initiative. So the cost to build a home in the core neighborhoods is generally higher than the appraisal price. And so the energy burden, added on top of that, the energy burden for low-income residents in Kalamazoo is also considerable. So the city, through a philanthropic arm and other nonprofits, provide funding for the property development and the buy down of these homes to make them affordable. And the market price, or the price at which they are marketed at, is $145,000 to income eligible buyers. The income eligible buyer here is one that has an area median income of 80% or less. So for a family of 4, that's an income of about $63,000 in Kalamazoo. The cost to build these all-electric homes, though, is probably closer to $200,000 all in. And so one of the nonprofit partners manages the construction effort and also functions as fiduciary to the builders. And so they pass on the utility incentives to the builders. They also offer mortgage products to qualified customers, and they're also the ones that help find the eventual home buyer. And so we support them there as needed. And so all 8 of the homes, the first 4 that were built in 2019 and the 4 all-electric homes have since been sold. And then finally, I'd mentioned the other partner, major partner here is the Home Builders Association of Western Michigan and its builders and local network of subcontractors. And there are 3 builders responsible for building the 4 all-electric homes, and they get paid $15,000 per home. The home builders and contractors spend years developing a brand that really hinges on the satisfaction of their clients. And so for many builders, even those that are interested in exploring all electric homes, just going outside of the tried and true construction practices could be very risky. And so this pilot really leads builders on a journey that challenges them to build to higher standards while offering the safety net of technical support through the subject matter experts brought in by ICF and through the financial support of the utility incentives that cover the incremental costs. And so with our builders, we've seen them build high quality dual fuel homes and then help them transition to building 4 Energy Star certified homes. And they've just this summer have kicked off their next round of homes, committing to building 7 homes and a duplex that are going to be zero energy ready. And so Kalamazoo is not as unique as many cities are in need of high quality, affordable housing. And so there may be a model here that can be replicated elsewhere. So I call this my house in a box, a picture. These Kalamazoo builders have really designed a house in a box that maximizes the construction efficiencies. For instance, the bathrooms are stacked to minimize the plumbing runs. These homes come in a 3-bedroom and 4-bedroom options with basements that have rough plumbing for a bathroom down the road. And essentially, they're spec homes that have identical floor plans to the dual fuel homes that were built in 2019. But the advantage of selecting measures in these demonstration homes for their performance instead of cost, or even relying on the preferences of a builder or homeowner. And so what we've done is really create an optimal situation for evaluating the feasibility and just fundamental questions of an all-electric home before we begin talking about a pilot expansion in phase 2. And so in that spirit, these homes feature, many of the usual suspects. We've got the latest in cold climate heat pump technology from Fujitsu and Mitsubishi with backup electric resistance heating, spray foam insulation to help with air sealing, and high insulations in the wall and in the attic. Since the homes are air sealed, pairing the heat pump with an energy recovery ventilator for mechanical ventilation just improves the indoor air quality and increased overall, efficiency of the HVAC system. We also have a heat pump hot water heater, the solar PV system, of course, Energy Star triple pane windows and appliances, and then a 240-volt line for level 2 EV charging. And so all in, the cost of these homes is about $200,000 to build on the lot, but continues to be sold at a price of $145,000 to stay attainable. So this is a shot of the main living area of the home. This is the 4-bedroom model, and behind the kitchen is a small office bedroom type room. For those of you who are interested in real estate, this is just one of the ways the Home Builders Association had adapted their parade of homes by offering these virtual walkthroughs. And so, in fact, we found it so useful in sharing the HVAC contractor with the HVAC contractors and even the evaluator to give them a sense of the homes. So in the residential new construction space, we talk about homes in terms of their ResNet Home Energy Rating System Index. And so in the index, a reference home would have a score of 100, and anything above or below that would represent the relative efficiency of the modeled home. And so a lower score is better here. And based on the final inspection by an independent rater, The homes as modeled are at a HERS 41 before the PV, and then a code minimum, dual fuel home would come in at about a 62. And so in this case, adding on the PV system, these homes drop down to a HERS 5. And if the PV system was sized a little larger, but remember we stayed conservative with it, then we would get to that net zero mark. So using our modeled results and comparing it to the dual fuel baseline home, there are significant savings. And so as projected, each home will realize about 75 MMBTUs, or about 70% in energy savings compared to a dual fuel home. That will translate to a 58% reduction in annual energy costs with the PV system. And that's just because of the current net metering rates. The home also will have a 91% reduction in CO2 equivalent emissions for the end use customer over that code minimum dual fuel home. But just knowing that the other presentations in this session are talking about buildings in terms of site EUI. So putting those energy terms into site EUI, we're talking about a building or home that's around 17 kBTUs per square foot per year. And so that's basically a stone's throw to passive house. With the PV systems, these homes do drop down to 2 kBTUs per square foot per year. And translating all of this to dollars, the customer's bottom line, that means customers will save about $1,300 a year in these homes. And that's very important for the energy burden residents of Kalamazoo. All right, so that was the technical results from the demonstration homes. But here's some insight into the early market transformation results. The Kalamazoo partners have been excited about the opportunity that this pilot has presented them and the community with. And that's the chance to build these affordable all-electric homes with technologies like the cold climate heat pumps, heat pump hot water heater, and solar PV system. And something I didn't mention earlier is that Energy Star certification was never a requirement of the pilot, but because the homes were going to be so efficient, and with the HERS scores as projected, before construction, we're going to hit the low 40s before PV, the builders and partners decided to pursue Energy Star certification. And for them, it meant bringing distinction to their community initiative, validating the quality of their builds, and developing a pipeline of qualified builders and contractors. As for the fiduciary, for them, it was an opportunity to tap into energy efficient mortgage products and offer that to their clients. And so Consumers Energy and ICF provided advisory support during the construction of the homes, and in assisting 2 of the builders and HVAC contractors through the credentialing process. So it's really obvious that the builders are proud of their work, and they regularly feature the homes on their Saturday morning podcast and on their website. And last month, the Kalamazoo City Commission celebrated the partnership through proclamation. And so the initial experience with the pilot program has led the Kalamazoo partners to committing their next rounds of homes for the coming years to be built to net zero ready standards. And so just having put time into establishing this relationship also means a potential pipeline of projects and builders and home energy raters participating in the programs, not just in the electrification program, but also just elevating participation in our Energy Star new home construction program as well. And so now I'd like to pivot to the phase 2 expansion of the pilot to market rate and affordable homes. And there's a long list of learnings and considerations as we explore scalability and market acceptance of zero energy ready homes. The phase 2 pilot kicked off early in the summer. And again, most of these considerations do fall along familiar themes, how to get more builders and homeowners bought in, And alignment with new codes, the federal certification programs, and industry trends for having homes that are more future ready. And it seems that really one of the most effective ways, at least on the residential side, has been through the Home Builders Association. The term house in a box makes things sound easy, but to take a line from one of my builders, building homes is a contact sport. And so therefore, just word of mouth, sharing of experiences of the pilot, and just offering that high degree of technical support to address experience and confidence gaps is a must. The other component is keeping the basic requirements for participation pretty straightforward. So the homes need to be completely electric. They need to be at a HERS 40, and this automatically implies that the builder has done some envelope upgrades. And finally, the homes are PV ready. In addition, there's bonuses for homes that exceed performance requirements. And then for builders that do miss that initial HERS 40, we do offer discounted incentives so that the builders do walk away with something. And of course, in the midst of this is trying to have flexibility for all the disruptions that are currently facing the building industry. And we can talk more about that in the Q&A. To the right are the specific incentives that we chose based on the phase 1 learnings. And we do offer roughly double the incentive amounts for the income qualified builders. I gotta wrap it up here. Phase 2 launched earlier this summer, and it has 17 homes in the pipeline, 2 of which are market rate homes that have been completed. And we've also got Habitat for Humanity affiliates participating. So pretty good start to phase 2, good response from the market, even at these incentive levels. And so as I wrap it up, it's still early days, but we are looking ahead to what needs to happen to keep the momentum going. And so part of this is increasing demand. Of all the tech we've talked about, the electric cooktop seems to be a hang-up for a lot of customers. And of course, if we can increase customer demand, we can increase builder confidence. There's quite a few things to work out in the calculation of cost effectiveness and what those levers would be. And there's the ever-present bottom line to the customer. What does this mean for them? And then a number of regulatory questions that need to be explored. At the end of the day, these are ratepayer funded programs, and there are requirements that we need to fulfill. At the same time, we do need to take that step into what homes of the future need to look like. And so for every challenge, the solution may actually be to respond to an opportunity that's on the flip side of that. And so with that, I'll hand it back to Arliss. Thank you.
Thank you, Cheryl. I know there's a lot of interest in the residential new construction, and as a Californian, I must say I'm particularly excited about the affordable housing for an all-electric and even net zero home. Just wanted to give a quick reminder to our audience to post any questions you have in the chat. We'll try to address those in our Q&A and then as well in the Zoom session after this call. So lastly, we'll hear from Jillian Winterkorn from Eversource Energy, where she's worked on the commercial new construction energy efficiency team for 5 years and assisted in developing a net zero energy program that was launched across Connecticut, Massachusetts, and New Hampshire in August 2020. Jillian will share strategies from her commercial and industrial new construction program that is advancing net zero energy buildings across those 3 states. Her presentation is titled "A Utility New Construction Energy Efficiency Program That Targets Zero Energy."
Thank you, Arliss. My name is Jillian Winterkorn. I work on the energy efficiency team at Eversource. I'm going to share my screen. All right, I think we're all set. Eversource is a utility. We operate throughout the tri-state area of New Hampshire, Massachusetts, and Connecticut. We're not only an electric company, but also natural gas and water. Our team is listed on this over to the left or your right, so you can reach out to any of them, or I can connect you if you have any projects going on in that area. So Eversource has a goal to be carbon neutral by 2030. What that means is we're looking for opportunities to reduce our own emissions as a company. And most of our greenhouse gas footprint is tied to line loss, but of course, we also have many buildings and our fleet as well. We formed an innovation team to actually come up with strategies to help us meet that carbon neutral goal. We're a utility that's focused on energy efficiency. About a 900 or about nearly a billion kWh in savings come through our program, which is equivalent to 115,000 houses. We're also putting forth a lot of offshore wind projects, almost 4,000 megawatts. So we're excited about that. We think that that is going to really add a lot of renewables to the mix in New England. And hopefully, as we go, we electrify, and then we also have a cleaner grid. We've seen a lot of growth in zero energy buildings throughout New England, specifically Eversource territory. And this is something that we didn't see a while back. When I first started at Eversource, zero energy commercial buildings was kind of a weird concept. And so we got together a team to discuss like what's going on here. What are the challenges here? We really want to push zero energy buildings that are first and foremost energy efficient buildings. And since that time, we've come up with a few strategies and have gathered the project teams, including architects and engineers and developers. And we've seen some growth in this area. So we're excited that from 2019, where we saw 7 verified buildings, we now have 10. Where we saw 16 emerging buildings, we now have 31. And these buildings, though a lot of them are school buildings and or college education, there is a little bit of variety. We're seeing offices, we're seeing warehouses targeting zero energy. We're seeing private and public, and we're seeing small and large. So there's a lot of hope for the future of zero energy, we think, in New England. So one study that we looked at, which came from Paul Torsellini recently, and some of you might be familiar with this, is that how much does it cost to go zero energy? How much more does it cost? That's always the question, right? So we've seen a whole bunch of answers that it's extraordinarily more expensive, or it's not more expensive as long as you're setting the goals up front. What this study shows us is that even if you're setting a low EUI target, it doesn't necessarily need to cost more based on the case studies that Paul showed in his paper. So that's what we want to do. We want to encourage these early EUI targets, but we don't want to necessarily make it cost double the price. We really want to make sure that we're setting these early targets so that we can find design solutions early on, and not later, where of course, like once the building is going up, changing your design is going to be much more costly. So this study was focused on schools, and we'll see how that plays out in different areas, but it does show that, okay, maybe if we have these early conversations, we can set EUI targets low and not necessarily spend a lot more money. So we wanted to build a program at Eversource focused on zero energy buildings. We want to support even more of these buildings. And to do that, we got together a group, a roundtable of different stakeholders, which include the utility, of course, and include our utility partners such as National Grid and Avangrid, as well as architects, consultants, developers, and engineers. And we listened to what challenges they presented to us. What issues are they facing? The architects will sometimes say, well, it's the developer that doesn't want the zero energy building, or it's the developer that he just wants to build fast and the architect came in too late. So we brought everybody together and we said, just make a list, document what's going on, and what support can we give you? What better tools do you need to be successful in building a zero energy building? So we built this program really around what the community told us. Our program launched last year, August 2020, so it's not as old as the Energy Trust program, but we're pretty excited about it, and we're getting a lot of new customers coming in. It is a 4 pathway program. The first path is our zero energy path, and this is the only pathway really focused on driving deep energy savings. But of course, we want to open to make sure that there is a pathway no matter what type of building you have. And we have pathway 2, 3, and 4 for that reason. We always supported zero energy buildings, but this is the first time we actually wrote it on the paper that said, if you're interested in going zero energy, come to us early. We have a program for you. So pathway 1, requires energy modeling. I'm going to go through with the other requirements. Pathway 2, very similar to Pathway 1, just you don't necessarily have that zero energy goal. And Pathway 3 and 4 are more prescriptive programs. We still want to make sure that we're pushing design teams no matter what pathway they're going through. Maybe a Pathway 3 project will come to us down the road with a Pathway 1 project. And that's the idea, to get everyone closer to Pathway 1. So Pathway 1, that's the one I'm going to take a deep dive into. You don't have to worry about the other pathways. It is our zero energy program. We require that projects that come to us have a minimum square footage of 20,000 square feet. And that's because we're putting a lot of money down for these projects. And we also need to provide savings. That's how these programs run from the utilities. We bring in projects, we're able to say these projects produce a certain amount of savings, and the state gives us the okay. It requires that project teams engage with us in feasibility or early schematic. There's more opportunity the earlier you engage. We don't want teams coming to us after they've already designed a building and just asking for an incentive. We require the project set a 25 site EUI, which we feel is generous. Based on the research we saw early on, we said, okay, we think that if these buildings are setting a 25 EUI, they're on the path to zero energy. But we're actually seeing projects come in much lower. They have 17 EUIs, a couple of projects just came in. So that's great. Maybe the next generation of our program will target even lower EUIs. The 25 EUI is for like a standard school building, something, or a standard office building. If there's a project that for some reason is going for zero energy but requires a higher EUI, we will evaluate that project. And we also offer a post-occupancy incentive through this program. We not only want projects that are modeled to be zero energy, but they're actually operational at zero energy. So what's the goal of setting an early EUI target? Sets a very clear goal. That 25 is very clear to the entire project team, whether they studied architecture or whether it is the state or the developer. It's a touchstone in the decision-making throughout the design. So every meeting that we show up to, we talk about the target. How far are we off from the target? How can we get to the target? Is there a second target that we're going for? It prevents value engineering because that target is always top of mind. So that's a really important thing. We see a lot of zero energy projects don't hit zero energy because something was value engineered and changed. We don't want to see that. We really want to make sure everyone's on the same page and has the same goal. And allows the project team to check performance against the target over time. We also provide a zero energy expert. So we see project teams come to us, they want to go for zero energy, but they don't know how to go for zero energy. So we bring in a zero energy expert. We have a list of approved experts, and we'll compensate 50% of the up to 10K. And this expert's really just meant to help get them on the right path, help them do some early modeling, help them do some early targeting. But it's just a kicker to get them started. We compensate 100% of the model, which is required by the program. There's customer incentives, there's certification incentives, there's design team incentives for the architect firm, and there's verification incentives. Incentives do vary per state, and that's because in Massachusetts, there's much bigger buildings. In Connecticut, there's a pretty good amount of funding compared to New Hampshire. So there's various reasons, but more or less, we think that we are being very generous in this program. In Connecticut, you can get up to $450 per square foot for participating. The verification scope, that is also on the table. We want to make sure, like I said, that these buildings are not only designed for zero energy, but they're actually operating at zero energy. So we have an optional incentive where we'll review the control system, we'll look at the trend data, we'll look at the EUI data to make sure that these buildings are achieving those goals. We don't necessarily penalize the project team, but it will help us learn as well as the customer of what's going on in the building. Certification bonuses, we're not picking one over the other. We want the project teams to go for whatever certification that they want to go for. We're trying to support all of them. We're trying to make sure that if they want to go for it and take that extra step, we provide some funding to help them. So Path 1 includes design incentives, modeling incentives, certification incentives, and owner incentives. We're really trying to get to the whole project team, or at least a substantial amount of members. And like I said, this is 25 is that if you're going for path one, you really need 25 or below. But however, if you fall out of that, we would bring you through our path two program. And that's okay too. We're at least glad that our project teams and customers are going for it. They're not going to lose their incentive if they don't achieve it, but we will reduce the incentive a bit. We have all our program resources on these 3 sites, not really a big talking point site, but if you want to learn more information, you'll have the slides and you can go to these web pages. And that's what I have for you. So thank you for being with us today, and we're happy to discuss our program with you anytime.
Okay. Thank you, Jillian. I'm trying to do the math here. I think we have about 7 minutes for a Q&A. Thank you to all of our presenters. And I want to just start with some of the questions straight from our audience. So Jillian, since you're still warmed up, we have a question from Rich Perry here. Does Eversource partner with data centers in pursuit of net neutrality?
Yeah, that's a good question. We will partner with any, here, Nicole, I think I'm good though. I haven't partnered with any data centers on my own, and there might be some work going on that I'm unaware of, but we work with data centers in all different types of buildings all the time on energy efficiency. I don't know how much they're involved in us getting to our carbon neutral goal. A lot of the work happening on our carbon neutral goal is very internal at the moment. Right now, we just have an innovation team that's just submitting ideas on how we can get there, and we're testing out which ones are feasible.
Great. And I want to stay in the non-residential buildings for a minute with a question for both Forrest and Jillian. You both mentioned aspects of your program that look at post-occupancy, which I thought was really interesting, especially Jillian, the incentives for post-occupancy, I think were in some cases even equal to the sort of design incentives. In Forrest, I think I saw some pretty hefty incentives related to energy metering, which I'm assuming is related to actual performance of the buildings. So can both of you, and we'll start with Jillian, talk a little bit about what you guys have seen between modeled performance and actual performance and some of the motivation around the post-occupancy support?
Yeah, so we haven't had, our program's relatively new. I think Energy Trust might have a lot more experience here. We haven't had a building completely go through to our as-built and post-oc. There's a lot of project teams that are excited about it. We have seen a lot of models that we require a preliminary model, we require an as-built model, and we require an as-built model 99% of the time because we find that there are always changes. And whether it's because there's more savings, maybe they installed better equipment, or maybe there's less savings. I had a project recently install all fluorescents, so that wasn't great. So it's quite variable, and I think the same thing is going to happen with comparing the as-built model to the post-oc. It depends how the building is used. So while we don't have that data, I think there's a lot of variability we're going to find.
Forrest, same question.
Yeah, so the Energy Trust program doesn't currently require certification or final verification of achieved EUIs. It's all confirmed on a model base, and that kind of came out of the pilot program. Just the engagement after completion of the project was difficult, and so actually collecting that data was a challenge. But for those projects actually pursuing net zero certification, there is an extra incentive to kind of get them to take that step. And then there is the incentive you mentioned for energy metering, which is to get sub-metering installed in the buildings, and also to develop either an energy dashboard or some type of strategy around using that data to inform how the building's tracking to the modeled EUIs. I would say from our experience in design, it really does vary based on how the building actually is operated. A lot of times these really high performance buildings, initial assumptions around occupancy may be off because once they get into the building, they really love it and they end up using it more than you would have assumed for a building of that type. Schools are in particular that way, just being used more as community centers rather than the typical school year occupancy. So those are some of the things that we've seen that kind of drive shifts in actual performance from modeled performance. And then obviously, as Jillian mentioned, there are differences that final completion of construction, there are things that change. So getting that kind of final updated modeling to be able to align and calibrate your metering is a way that we've gone through and actually helped projects that are pursuing full net zero certification understand where gaps may lie and helping dial those things in post occupancy.
Yeah, great. I'm imagining all the extra energy use associated with demonstration tours for great net zero projects in the community. So let's jump over to residential. Cheryl, we had a couple questions from you for our audience. First one, really simple. Is there a pilot page with more information about the pilot programs?
We do have a builder-facing website. It's actually Consumers Energy Trade Allies site that I can share at some point. I'm not sure how to drop it into the chat. But by all means, look for Consumers Energy. I think it's called All Electric New Homes, and you might find it.
Maybe you can put that in our private chat and we can push that out, I think, to the main chat. Let's try that.
I'll do that in a little bit.
But I'm going to ask you one more question in the meantime. This is from Maureen McNamara, who's curious as to how the costs of the homes were compared to non-net zero. So what is sort of the incremental cost of the projects that you were working on?
Yeah, so I'm assuming you mean non-net zero, meaning before the PV. So if we're just doing the all-electric home compared to the dual fuel home, let's say, we know that the summertime bills would be about the same just because, a heat pump is basically like the air conditioning unit anyway. So the biggest difference would be in the winter bills. And even though the homes before PV use 70% less, the all-electric homes use 70% less energy because of just the differences in gas and electric rates, the homes end up being equivalent. So they're on par, and as modeled, the electric homes come out 10% better than the dual fuel. But just as Forrest mentioned, there's a difference between modeled and actual, and families live in their homes differently, and there's different household sizes, and so all of that needs to be taken into consideration. We do have an independent evaluator looking at bill impacts over the course of a year. So more to come on this one. I hope that answers your question, Maureen.
And if it doesn't, Maureen, join us over in Zoom. We're at the end of our hour here on the main session. So I want to thank our speakers, Cheryl, Jillian, and Forrest, for their presentations, and to all of our attendees for participating in today's webcast. As we mentioned at the beginning, we've got 20 minutes. We're going to move over into a Zoom session. You should be able to grab the Zoom link from our chat here. But thank you again to all of our speakers, audience, and of course, sponsors of ACEEE. And hopefully we'll see you over in Zoom. Thank you.